Welcome to Shipcalculation.com. For any inquiry, you can email us shipcalculation@gmail.com. WhatsApp/call +62 821 1448 3491. The existing crane pedestal strength calculation. So this calculation is based on the existing crane pedestal to determine the maximum vertical load, turning moment, and torsional moment. So the drawings is come from the other vendor, and then we have to check also the thickness measurement report. Okay, based on this, the tube or crane pedestal itself is this is the dimension. Can see here from the drawing, right? The sketch drawing is the height from the deck is 3.5. Okay, and then the thickness is 0.055 mm. Okay, this one is the material you are using to be tensile strength. To be high tensile strength is EH36. Okay, EH36. This one 355 the yield strength. Okay, and you just change the information here. Let's say you have the all crane, but you don't have you don't know the maximum vertical loading, turning moment, and torsional moment from this the bar head, because this the crane pedestal is the penetrate till to the bottom the deck plate is because it's quite huge crane. Okay, and then the plate thickness also, you can change this one, the bottom thickness, how much the bottom thickness, the deck plate thickness, how much. So you just change this here. Vertical longe bar height thickness also got the vertical longe bar height, right? So how much the thickness. The yield strength is here. This one is 235 because this the other area, right? Like the deck plate and then the bottom plate. So if your current shape, the deck plate, main deck or bottom, you are using the mild scale, so you have to just put 235 here. But if you are using the high strength EH36 or 355, so you just change this one to be 355 megapascal. Okay, and then all this one is the information. So this the all the information is the comes from your current input. Okay, on the current input, so you just change to make it the same. Okay, and then this is the how looks like the crane pedestal or tube. See, install on the main deck. Okay, and then penetrate till to the bottom plate. Okay, so the outer dimension is the 3.815 meter, and then the inner dimension is 3.705. The height from the main deck is 3.5 meter. Okay, and then the thickness is 0.055 meter. So this one is the longe bar head. There's a longe bar head, and then this one is penetrate. The height of this crane pedestal total is 8.770. So the height here 8.770. So you just key in here this one, the length of tube or pedestal, and then the inner diameter. You got a 3.705, right? 3.05. So you just key in. The others, this one is automatic from 3.815 here. You got a automatic, right? So you don't need to change, and then you will get the moment of inertia. Okay, the moment of inertia is a v. Okay, the diameter outside. Okay, minus diameter inner diameter, slash 64 divided 64, so you will get the moment inertia. Okay, and then also you will get the critical load. So the critical load will be how much the critical load. So this the critical, you cannot more than this. Okay, this one is something like the buckling, we become with the buckling. buckling of this pedestal. Okay, so this is the setting of the bottom plate, the setting of the bottom plate. Okay, the setting, okay, the resistance to shear of the bottom plate. So this one is all the this formula is automatic, you don't need to change. So you don't need to change this one, like the bottom plate thickness just now is on the on top. Outer area resistance is also got the formula. Inner diameter of tube also got the dimension. Inner area resistance is also got the formula. The total area resistance here is this one. Ultimate shear strength of mild steel also. So this one is the automatic. So we got the was required to punch the hole on the bottom hole is 13,000 or 004. So was required on this the bottom plate. Okay, so this one also we have to double check the strength of well resisting vertical load in the longitudinal bar head. Here got the longitudinal bar head, so you have to double check vertical longitudinal bar head thickness how much. And then this one is the throat thickness also. This one is the throat thickness of the welding. Okay, so total length of weld along tube is 21 meter. Okay, so total length, how much, and then the throat area times this. So you will get the strength of the side fillet weld also around this side. So around this side you will get how much. Okay, and then the resistance of the vertical loads is how much, this one also how much also. So all the this formula is automatic, you don't need to change. So whatever the red one you just change this here, change, and then the material elastic modulus, and then the modulus of rigidity also you have to check change. So the maximum allowable vertical force is around 20,830 tons. So because this one is the additional from the we add from the resistance vertical load on the bottom, and then on the vertical load on the deck plate, and also in the bottom plate for the shearing force. Shearing force. This is resistance to shear. And now we have to double check the moment. So the bearing strength on the moment bearing strength of the deck plate how much. This one also you don't need to change. You don't need to change because this one is the automatic formula. Okay, automatic formula. So like the auto diameter of tube or pedestal, it comes from the on top this calculation. Okay, so projected area also got the formula. Allowable stress in comprehension also is already got formula. Allowable bearing load also have the formula, so you don't need to change this one. And then now you check the strength of the deck plate against the tearing. Tearing also got the formula here. Okay, here got the width of the double plate. So you are using the double plate also into the deck, right? So got here the doubler. So you have to double around this side, and then the double also around the bottom plate now. You have to double check also. Okay, the hull got against terrain, strength of weld in resistance horizontal load, also the longitudinal part also you have to check hull structural resistance against the moment, also you have to check how much the tube resistance against the bending failure. So the tube resistance also against the bending failure, you have to check the this one is automatic also, so you don't need to change everything here. You don't need to change. So what you just change all the what I call it, the red one. Okay, the red one, and then you will get the maximum allowable moment, the torch from the auto diameter in the polar moment of inertia got the formula. Also rigidity, and from the on top allowable angle of twisting, the height from the mandate also is called. So now we get the maximum allowable torch is 8,819 kilonewton meter. So the summary here got the maximum vertical load from the shear resistance is 20,830 ton. Maximum turning moment is 1,219,1951 so kilonewton meter. So maximum torsional moment is 8,819 kilonewton meter. So all this the summary, all the this the output, the result of the calculation. If you don't know exactly our existing what they call it, pedestal, clamp pedestal, so you just follow the all the dimension. Okay, so this dimension is just like the guide for your engineer, and then you have to double check all the book also. So this is the guide only. Okay, so don't forget to subscribe to our YouTube channel Shipcalculation.com. If you need shape calculation and shape design drawing, you might contact us at the following email: shipcalculation@gmail.com, WhatsApp/call +62 8211448391, office call +62 7784808 127. You might visit our website www.shipcalculation.com. Okay, thank you very much for watching. See you again, and bye bye.